Now that we've talked a little bit about Venn diagrams and probability, let's talk about some of the laws using Venn diagrams and probability. And actually, this applies to all probability, not just Venn diagram probability. So let's use this generic Venn diagram to talk about the probability of finding the union of sets A and B, or you can think of this as the probability of A or B chosen at random from this Venn diagram. So the favorable results will be A plus B plus C. All of these items are within the union of those two sets, and we'll divide by the entire sample space, which is A plus B plus C plus D. That represents all of the possibilities inside that sample space. So keep that in mind what A or B is. The probability of selecting A is going to be everything inside of set A, which is A plus B, and that's also over the sample size, A plus B plus C plus D, or sample space rather. And the probability of B is going to be given as B plus C over A plus B plus C plus D. And finally, I want to do one more thing here where I want to find what the probability of A plus the probability of B minus the probability of A and B, or the intersection of A and B. So that would be this space right here. Let's find what that is. Well, I know what the probability of A is. That's going to be given as, actually, let's go another color with this here. The probability of A is going to be A plus B over the sample space, A plus B plus C plus D. That is this, plus the probability of B. So that is B plus C over A plus B plus C plus D. That's this. And then let's finally subtract the probability of the intersection A and B. So that's going to be this space here, B, and that's over the sample space again. A plus B plus C plus D. That is this right here. So if I actually combine all of these things, all these denominators are equal, they're equivalent. So really what's going to happen is I'm just going to add across the numerators. So what's going to actually cancel out of this is going to be, I'm subtracting a B here, and it doesn't really matter which B I get rid of. Let's get rid of this one. So this B and this B will cancel. This is basically becoming 0. And so I can combine all of this to become A plus B plus C over A plus B plus C plus D. Now, wait a minute, that looks a lot like this, the union of A plus B. So what do you know? I can calculate the probability of the union of sets A and B by taking the probability of A plus the probability of B and subtracting the intersection of those two things. And that should make sense because everything inside of these circles is going to be what's in these circles, and I just have to make sure that I count that B only once. So, I mean, you can look at this and just think of this as, it should come out to be A plus B plus C, and that should be quite simple. But if I don't know what all of these values are equal to, I'm going to need a formula like this. So we'll see what some examples like that look like. You can think of this visually as all the circles, everything filled into those circles is going to be each of those individual circles together, but I have to subtract out one of these little slivers so I don't count it twice. If I were to merge these two circles together as it is, then I would be double counting this piece right here. So before we get to some examples, let's talk about some more laws of probability. Mutually exclusive events. We talked a little bit about this earlier. We'd say that two events are mutually exclusive, or if two events are mutually exclusive, then the probability of their intersection is equal to 0. That should make sense. They do not intersect at all, so there's no chance that both events can happen at the same time. The addition law becomes the probability of the union A or B is equal to just the sum of those two probabilities. Probability of A plus the probability of B. I don't need to subtract out the intersection because there is no intersection. And again, think of this with like aces and kings. These are mutually exclusive events. So if I wanted to find the probability between these two sets of cards, that I would draw either an ace or a king. I'm just adding up the probability of drawing from this plus the probability of drawing from this. There's no overlap there. Let's talk a little bit about conditional probability. Again, we've kind of seen this before, we just haven't really called it with these terms. So given two events A and B, the conditional probability of A given B, and this is kind of where it gets tricky with the vocabulary, that is the probability of, it's the probability that A, the event A, occurs given that B has already occurred. So this just means that A can be affected from the probability of B already occurring. Not always, but this is what is important is the chronology of these events. When it says A given B, that means B happened. What's the probability of A then happening after that? You'll see the probability written with this notation, A in this vertical line B, and it's read as A given B. So if A and B are events, then the probability of A given B is given by the probability of the intersection of A and B divided by the probability of B. And this seems like a whole lot of just random weird formulas, but again, think about where this comes from. If I take the probability of B, so this is the probability of B, that's like this. This is my blue shading right here. All of this shading is the probability of B. I want to know what the probability of A is inside of this probability of B. And the only place that that's going to happen is right here. This is the only place where A occurs in B. This notation of A given B means that B has occurred. This circle describes where B has occurred. And if I want to talk about where A can then occur, that is only within this segment here, this section here, which is where we get that intersection of A and B. It's kind of like I'm taking, this almost becomes my favorable result, and this becomes my new sample space. I'm dividing, to find this probability of A given B, I'm taking the possibility of this small section out of the full section for the event B. And so you can write this in different ways. You can multiply both sides by the probability of B, and this kind of works both ways with A given B and B given A. They're pretty comparable to each other. All right, so let's dig into some examples. We're going to use one of these probability laws. If I have the probability of A is equal to 0.6 and the probability of A or B, or the union of A or B, is equal to 0.7, and the probability of A and B, or the intersection of A and B, is equal to 0.3, find the probability of B. So the first thing I should do is let's recall that, that addition formula that I had before. So I have the probability of A or B is going to equal the probability of A plus the probability of B minus the intersection, so the probability of A intersected with B. And really at this point what my strategy is everything that I know I fill in, and everything I don't. So let's see what I know. I know that I've got the probability of A is 0.6, so this is going to be 0.6. The probability of A or B, or the union of those two sets, is 0.7. The probability of A and B is 0.3, so I'm going to subtract 0.3. And the unknown is still the probability of B occurring. And so at this point, it becomes a little bit of simple algebra. So 0.7 is going to equal, I can combine these terms to be 0.3 plus the probability, plus the probability of B. I subtract 0.3 from both sides. The probability of an event B occurring is equal to 0.4. So why is this useful? Well, if I have two events and I want to figure out, and I know the probability of them both happening, or I know the probability of any of them happening, that might not necessarily give me the pure probability of one event. So sometimes it's easier to figure out the probability of one thing by looking at the probability of it combined with other events. So you'll see where this becomes important later on down the road. So why don't you try this example here. It's a very similar problem. We're using the addition law. Pause the video and give this one a shot. All right, and here are is my solution for this example. Take a look at my work, and hopefully it went okay for you.